let's do some examples of finding derivatives from the rules. Specifically, we're going to use the constant and power rules in this video. So we're going to want to find each of the following derivatives. We want the derivative of x to the 3/2, the derivative of pi, the derivative of 1 over x cubed, and the derivative of 1 over the square root of x. Remember this notation right here, d over dx, that means take the derivative of whatever's inside here. It is a function whose input is another function. It means take the derivative of what's inside. So I highly suggest that you try these on your own and then see what the correct answers are. It's a form of quizzing yourself to make sure that you understand the process. The point of doing these is so that you get very quick at finding derivatives. It involves a lot of algebra, so try it on your own first. So first is we want to find the derivative of x to the 3/2. So this is of the form x to the n, where n is 3/2. Okay, it's x to the 3/2 power. So our derivative is 3/2 times x to the 3/2 minus 1. Notice what's happening here. We take our 3/2, we drop it down in front, make it 3/2 times, and then we subtract 1 from the exponent. And so in all we get 3/2 times x to the 1/2, or 3/2 times the square root of x. Okay, so now the next one, dx of pi. So we want to find the derivative of pi. Now how does this fit in? What kind of function is pi? Pi is a number, so this is a constant function. If I thought about what the graph was, it would be a horizontal line right at the y value of pi. Every input has an output of pi, so its derivative is 0. The derivative of every constant is 0. Okay, anytime you take the derivative of a constant, it's 0, no matter what form that constant is. So let's find another one, 1 over x cubed. Now be careful, before you say this is a power function, you need to remember that the derivative of a power function only works with the power rule if the entire function looks like x to the n. It does not mean if x to the n appears somewhere, that's what we do. The entire function has to be x to the n. So we need to rewrite this. Oh, let's back up a little bit. Okay, we need to rewrite this as the derivative of x to the -3. Now we have this as just the whole function is x to the power -3. So our n here is -3. So now we can use the power rule, and we get -3 times x to the -3 minus 1, which is -3 times x to the -4. You can even write this as -3 over x to the 4th now, if you like. You don't have to, but you can. You just remember what that -4 exponent means. Okay. Now our last one, let's take the derivative of 1 over the square root of x. Now remember, we want this to write this. This is a power rule because we can rewrite this function that we're taking the derivative of as x to a power. Make sure, pause it, make sure that you can do that right now. So now I'm going to do it. I'm going to rewrite this as the derivative of x to the -1/2. Negative because that x to a power is in the denominator, and 1/2 because it's the square root is the 1/2 power. So here our n was -1/2, so we took the -1/2, put it out in front, and we get -1/2 times x to the -1/2 minus 1, which is -1/2 times x to the -3/2. Okay, if you really like, you could rewrite that as -1/2 times this times 1 over the square root of x cubed. Okay, you need to be able to go from the top, from the 3rd line to the 4th line, but that doesn't necessarily mean that you always have to rewrite it like this. It just means that you need to understand that x to the negative 3 halves is the same as 1 over the square root of x cubed. Okay, these were all examples of finding derivatives of power functions and constant functions. So in the subsequent videos, we're going to use some of the other rules with this rule mixed in.